Hi, this is Mrs. Boland helping you with the last couple of problems of our lecture from Thursday. A couple of problems we were not able to cover due to time, and I just wanted to make sure that we covered those before Tuesday's exam. So this is problem number 10 right here, which is right here today. And because I don't quite have enough room to actually go ahead and do all the work on this page right there, we're going to do the work right down here. And we're going to get started with this particular problem. You're going to remember that one of the first things we wanted to do when we had two radicals is or any radicals, or any of the functions rather, is we want to assess the domain. So we're going to look at the domain to begin with. And the first thing we want to look at is there a fraction with a variable in the denominator? Well, we don't even have a fraction in this particular problem, so we don't have to worry about that. But we do need to worry about the fact that we have two radicals. And you're going to notice that on each of these radicals that we have an even index. The square root is what we're taking. Remember, whenever we're taking the second root, the fourth root, the fifth, the sixth root, the eighth root, any even number, 2, 4, 6, 8, 10, 12, that we must make sure that what is underneath the radical always remains positive, or the number 0. So we have two restrictions in that case. We have that 2x plus 3 must be greater or equal to 0, and then we have x plus 2 must be greater or equal to 0. Both of those items must be true in order for our function to work properly. If we put in a number that is not does not qualify and keep both of those restrictions true, then we have broken our function and broken rules. Okay, so as you know, we always start with all real numbers, and then we remove whatever numbers would break the function. So let's go ahead and solve the left side over here. First, we'll subtract 3 from both sides, and we end up with 2x has to be greater or equal to negative 3. And then we will divide both sides through by 2, and we get, therefore, x has to be greater or equal to negative 3/2, which is indeed the same thing as negative 1 1/2. Okay, now on the left, right hand side rather, we'll subtract 2 from both sides, and we get, therefore, x has to be greater or equal to negative 2. Let's look at a picture of that so that we can see a little bit better what the domain looks like. If we just draw a number line right here, and we put 0 right here, we put 1, 2, 3, so we have negative 1, negative 2, negative 3. Our first one right here, we're going to put at the negative 1 1/2 and highlight to the right because it says we must be greater than. The second one right over here with our 2, it says we have to be greater or equal to negative 2. So we're going to look at the areas that overlap that are common to both, aka the intersection. And that would then say that for our domain would be x such that x has to be greater or equal to negative 3/2, which is the same thing as negative 1 1/2. So that is our domain. So when we solve our problem, as long as our answers are greater or equal to negative 1 1/2, we are set. If not, then we have found an extraneous solution which will not be part of the solution. We would cross that off. Okay, so here we go. So the first thing we want to do is we want to take this radical right here and move it to the right. And we'll do that through addition. So we'll add the square root of x plus 2 to both sides of the equation. We'll draw our equal sign and add straight down. And now we have the square root of 2x plus 3 is going to be equal to 2 plus the square root of x plus 2. So the next thing we want to do is we're going to square both sides, because when we square both sides, that will indeed remove this radical on the left-hand side. And that's really what we want to do. We want to get rid of those radicals. So on the left-hand side, we end up with 2x plus 3 is equal to, because we squared it, okay, it's going to be equal to 2 plus the square root of x plus 2 squared. So we're going to write it out and we're going to FOIL it. Okay, so the left-hand side, again, we're just going to copy that down, 2x plus 3, and now we're going to FOIL the right-hand side. So the first thing we're going to do is we're going to go 2 times 2, which is 4. The next thing we're going to do, that was the inside, FO, right? So now we're going to do the outer. So we're going to go 2 times the radical part. So this is going to become plus 2 on the radical of x plus 2. Now we're going to do the inside, okay? And we're going to actually, when we do the inside, end up with the exact same thing that we did the last moment, which is 2 on the square root of x plus 2. And then the very last one right here, which is going to be the square root of x plus 2 times the square root of x plus 2, which then equals just x plus 2. So it's going to be x plus 2. Now we're going to combine like terms on the right hand side, noticing that I have a 4 right here and a 2 right there. So those are like terms and will be combined. And then notice that this right here and this right here are like terms, so we can combine those. So the first thing we're going to do is just copy down the left hand side, 2x plus 3. We haven't done anything, that just stays the same. Now we're going to add the 4 and the 2, which gives me, it's going to be 6. Now I'm going to add the x, so it's going to be plus x, and then I'm going to add the 2 on the square root of the square root of x plus 2 plus 2 on the square root of x plus 2, and that is going to give me 4 on the square root of x plus 2. Okay, all like terms have been combined. Now what I want to do is I want to take and move my 6 and my x to the left hand side over here. And I'm going to do that through subtraction. So I'm going to subtract 6 from both sides of the equation and subtract x from both sides of the equation and then add straight down. So 2x minus x just gives me x, and then 3 minus 6 gives me a negative 3, and that is going to be equal to 4 on the square root of x plus 2. Now I still have a radical, don't I? I need to get rid of that. How do I get rid of the radicals? I square. So again, I'm going to square both sides. So I'm going to square this side and I'm going to square this side. Because remember in algebra, what you do to one side, you must do to the other side. So when I do that, please go ahead and take a moment and write down the x minus 3 expanded out. Don't just write down what you think the solution is, especially on exam. Chances are you're going to make a mistake on the middle term. Now on the right hand side, 4 squared is 16. X plus 2 underneath the radical squared becomes just x plus 2. Make sure you have those parentheses because we're going to have to distribute the 16 to both of those terms there, the x and the 2. On the left hand side, let's go ahead and FOIL. So I have x times x, which is x squared. I have x times negative 3, which is negative 3x. I have negative 3 times x, which is negative 3x. Negative 3 times negative 3 gives me plus 9. On the right hand side, 16 times x is 16x. 16 times 2 is plus 32. I want to combine like terms on my left hand side. Notice on the left hand side that I have like terms right there. I want to go ahead and combine those before I move the 16x and the 32x over. So that would give me x squared minus 6x plus 9 is equal to 16x plus 32. Now we're going to move the 16x and the 32 over. So this is going to be minus 16x minus 32. and we're going to add straight down. So I get x squared. Negative 6x minus 16x is going to give me a negative 22x. 9 minus 32 is going to give me a negative 23, and the right hand side equals 0. Now I have a polynomial. In fact, I have a quadratic equation that is factorable. So I will go ahead and factor. So the first step of factoring is always put down your parentheses. The second step here is you see your x there. We're going to put an x here. We're going to put an x here because our coefficient was just 1. We're going to look at the sign of our c. We see that it is negative, and that tells me that I have opposite signs. So I have a positive and a negative. Next, I look at my factors for 23. It's a prime number, so it's only 1 and 23. Those are the only two factors that I can have. So that means I then look at my second sign right here of my b. It is negative. So that tells me my larger of the two factors must be the negative number, the absolute value of the larger of the two. So that means I'm going to put a 23 right here and a 1 right there. And that quadratic equation has now been factored. Now we're going to set each of the factors equal to 0. So we have x plus 1 equals 0, x minus 23 equals 0. Subtract 1 from both sides, and I get therefore x is equal to negative 1. I'm going to add 23 to both sides on this one here, and I get therefore x has to be equal to 23. I compare both of those answers to my domain. My domain said that x had to be greater or equal to negative 1/2. Well, negative 1 is indeed greater than negative 1 1/2, and my positive 23 is way over here. So both of those are fine. So therefore x is equal to negative 21 and 23. Alrighty, I hope you found this video beneficial, and I will see you in a moment on the next one.